give you a quick overview of the equipment used in the experiment to measure the half-life of muons. There are two main components, the scintillator detector and the multiplier tube, and this box that has electronics to process the signal from the PMT. And also we'll need a oscilloscope if you want to check different signals and understand how the equipment works and adjust the settings that we want to use. And then there is a PC that controls the data acquisition from the electronic box. But it's a bit more detail, but just to have an overview, here inside is the cylinder. We have first a scintillator where the muons interact with the scintillator and produce a light signal that is collected by a photomultiplier tube that is also inside. And the two other components that we have inside are a high voltage supply for the photomultiplier tube and a pulsar, light emitting diode LED pulsar that gives us a test source to debug the setup. Then in the electronics box we have essentially three components: a discriminator, an amplifier. First the signal of the PMT is amplified by the amplifiers, and then it goes to a discriminator that sets the timing for the signal, and then they go to a PHY, so programmable field array. It's an electronic component that does a variety of functions. In this case, it's programmed to do the timing and communicate with the PC for the data. We can look now more closely. So we have a number of connectors. So if you see from the top of the scintillator cylinder, we have a cable that brings the power for the whole unit. There is one knob where we can adjust the high voltage applied to the photomultiplier tube, and then from these two connectors we can monitor the high voltage. So this gives us a value of voltage that is 100 of the actual high voltage, and then we have the output of the PMT comes out of this PNC connector. And the things on the right side are all for the pulsar, so we can either switch on or off this LED pulsar, adjust the time between pulses, and this gives us an output of the pulsar to monitor what it's doing. And then if we look at the electronics, we have an input of the photomultiplier here, and then two outputs, one from the amplifier and the other for the discriminator, that let us monitor what is the output of these two parts of the electronics. We are not going to use this during the measurement, just for monitoring. Then we have a control of the threshold of the discriminator, and we can monitor the value of that threshold out of this, measuring the voltage between these two points. And this switch is just to have a beep each time we have a successful muon detection. So then in the back end of the electronics we have two important connectors. This one is the output with the power to the photomultiplier, so this is the other end of the cable, and the second, this output is a cable that connects to the USB in the data acquisition computer. So there is some adapter here, and then that goes to this USB port. The only connection we have to do to run the experiment, in principle, is connecting a PNC cable to the output of the photomultiplier. I'm taking the other end of the cable, connect it to the PNP input in the electronics box. So if we were to believe that the settings are well adjusted, we can just turn on the data acquisition program here and start collecting data and measure the half-life of the muons.